Okay, so we've done graphing quadratics in Vertex form. We're going to do quadratic word problems with Vertex form. And I haven't looked at this in a while, but when we're doing word problems, I like to tell my students we need to think about what a parabola looks like. And I tell them there are really only 4 kinds of questions. So one is, where does it start? One is, where does it stop? How high does it get? Or what time or how far is it at its highest or lowest point? This can be the highest or lowest point. This can be what time or what distance, something like that. Did it get its highest or lowest point? So those are the things we're going to have to answer. There are only really 4 questions that get asked. Because there are really only 4 interesting spots. I mean, you could ask, at 10 seconds, how high was it? But you have to have a special reason to ask that question. All right, so the fish population in a certain part of the ocean as a function of the water's temperature is modeled by, this is degrees Celsius. Let me put it over here. P of x is equal to -2 times x minus 9 squared plus 200. And you'll remember our vertex form looks like y is equal to a times x minus b squared plus c, or sometimes you'll see y minus c is equal to a times x minus b quantity squared. And our vertex is at b comma c, the x value, the y value here. So we can see our vertex for this is going to be at 9, 200. And so the question is, what temperature will result in the maximum number of fish? So that's asking for the highest point, and here's our temperature in Celsius, and here's the number of fish in thousands. So when it's 9 degrees Celsius, there are 200,000 fish. So vertex form is really great for this. If you want to find out the maximum or minimum, vertex form is the perfect form for that. All right, next, an object is launched from a platform. Its height in meters, x seconds after launch, is modeled by, where am I at? There I am. H of x is equal to -5 times x minus 4 quantity squared plus 180. So now we know that first of all, it opens down like this, because if a is greater than 0, then it's going to open up, and if a is less than 0, then it's going to open down. So it looks like this. And our vertex is at 4, 180. 180 means the height, and 4 means seconds. So what was the height of the object at the time of launch? So we're asking for this right here. Okay, we're not asking for excuse me, not asking for how high it is. So asking at the time of launch, at the start, where was it? And how we solve those start problems is we set x equal to 0. How we solve the end problems is we set y equals 0. So x equals 0. So let's plug x equals 0 in here. So if 0 minus 4 is -4, squared is 16. 16 times 5 is 80. -80 plus 180 is 100. So it's going to be 100 meters high. All right, our next one. Ying is a professional deep water free diver, so I think he's going to be diving under the water. So his altitude in meters relative, let me draw a different one here. Okay. I think he's going to look like that. So we're either going to want the deepest point, or how deep, or where did he start, or when did he come up, something like that. So let's see. His depth, his altitude in meters relative to sea level x seconds after diving is modeled by, how deep is he? 136. So he's not going very deep. And x minus 60 squared minus 100. So we know that our A is 136. It opens up, but 136 means it's really, like a plate and not like a bowl, not like a cup. Okay. X minus 60 minus 100. So my vertex is going to be at 60, negative 100. What is the lowest altitude Ying will reach? Well, at 60 seconds, he's going to be at negative 100. And the question is, what's the lowest altitude? What is this? What is this y value? It is right here at negative 100. All right, and we have one more. A hovercraft takes off from a platform. Its height in meters, x seconds after takeoff, is modeled by, and so it's a hovercraft, so it's probably going to look like this. Our last one is height. H of x is equal to negative 3 x minus 3 quantity squared plus 108. So we can see A is negative 3, so it's opening down, and our vertex is going to be at 108. There we go. So at 3 seconds, it is going to be 108 meters high. How many seconds after takeoff will the hovercraft land on the ground? Land on the ground. So that's that ending point there. So we're trying to figure out y equals 0. So we have to solve this. 0 is equal to negative 3 x minus 3 squared plus 108. And then we solve that by subtracting 108. And then we divide by negative 3. And that makes it 36. So x minus 3 quantity squared is equal to 36. X minus 3 is equal to positive or negative 6. I'm going to add 3. So 6, it's 9 or negative 3. So it looks like this, and then it comes out over here at x equals minus 3 or x equals 9. But we're not interested in this negative 3 point. We're interested in that 9 seconds point. When does it land? 9 seconds. All right, and that's how we do vertex form word problems.